Hey everyone, welcome to day 11 for Math 133. Today we're going to cover the Chapter 5 review, and we're also going to start working on the sample midterm. So the sample midterm is due on October 16th. So you have plenty of time to do it, but it is pretty big. It is 14 pages, and so we're not going to be able to do it all in one class. And actually, the class that we were going to talk about it, October 14th, we're not having any class. So we're going to cover a little bit of it today, a little bit of it on Tuesday, and Thursday next week. Okay. And any of it that we don't get to cover, we will get a chance to work on it uh, in Cindy's class. So Cindy's got you covered. Um, the midterm is coming up October 16th. And for the midterm, you're going to be able to, if you're taking that class with me, if you're taking the midterm with me in Zoom, then it's going to be October 16th, and it's going to be at 6 p.m. We're going to get started at 6, and we're going to go until 9. Okay. Um, so it takes about 3 hours. So it probably won't take you a full 3 hours. So um, the midterm exam is going to be 9 pages. So how do we compare that to time? So the chapter 5 review that we're going to do today, it's going to take us about an hour, and it's 4 pages. So if you can do 4 pages in an hour, then that means you can do 8 pages in 2 hours. And the midterm is 9 pages, so it's a little more than 2 hours. Okay. Now on the other hand, you are welcome to take the midterm at the testing center. You can take that on Tuesday, Wednesday, or Thursday. Tuesday, Wednesday, Thursday, or Friday that week. So October 14, 15, 16, or 17. If you're planning on taking it October 17th, you're going to want to set up an appointment with them because their hours at the testing center are not all day long. But anyway, so I'll be sending out a survey for you very soon, asking what your plans are for the midterm. And if you don't know, that's okay. And if you change your mind, that's fine too. I just need to know how many copies we need to have printed for the testing center. Um, the other thing to mention about the midterm is I'll be sending out an email, so keep your eye out for that. It's going to talk a little bit more about what to expect, a little bit more about the details. So, for example, you need if you're taking the midterm with me on Zoom, I need to be able to see you, and I need to be able to see your screen. Okay. Because I need to be able to see that you're not, getting on Google, you're not getting on AI or anything like that. Okay. So, if you don't have a webcam or, a lot of people, what they'll do is they'll log into Zoom, and use their webcam so I can see your face. And then they'll also log into Zoom on their phone and point that at their screen, their workspace area, so I can see what they have up. Okay. If I am not able to see you and your screen, you are not going to be able to take the midterm. Okay. Even if you join with me at 6. So that's a problem, right? So make sure you're able to do that. And like I said, I'll be sending an email that has more of those details so you can take a look at that in a little bit. Okay. Okay, cool. So the midterm is going to cover chapters 1 through 6. So today we're assigning the 6.1 lecture notes. So we're almost through our lecture notes for the midterm stuff. So starting chapter 6 today, try to get those done before Monday because Cindy's going to use those 6.1 lecture notes for some worksheets on Monday. Um, yeah, so, and then we'll do a cumulative review, and then chapter 6 review will be next week. Okay. So the chapter 5 review today is on page 390. Okay. Chapter chapter 5 review, page 390. Okay. And let me start my visualizer. so you guys can see my paper here. All right. In addition to the Chapter 5 review, we're going to be doing the sample midterm, and so you'll want to grab that as well, and that's going to start on page 424. Okay. But for now, the Chapter 5 review, page 390. All right, so a game at a fair consists of tossing a fair three-sided die and spinning a fair wheel with three colors. Okay. So construct a tree diagram. So the tree diagram for this is just going to be like this. Okay. So you write out the possibilities for the first, and then you split off that, and you write out the possibilities for the next one. Okay. Also list the sample space. Okay. So the sample space is all possible outcomes. Okay. So we're talking about probability in chapter 5. And um, when we're talking about probability, uh, it is a fraction, okay, or a proportion or a percent, right? So we're going to be dividing. So to calculate a probability, it is the number of wanted outcomes divided by the total number of outcomes, okay? So the sample space is going to help you not only with the total, figure out how many different outcomes could happen, but it's also going to help you a little bit when you're trying to figure out the wanted part, the numerator, okay? Okay. Uh, we've talked about disjoint, or no, so disjoint and not disjoint, independent, dependent. You'll find that information on page 135 and page 143. So disjoint means you have two events that cannot happen at the same time. Okay. Same time. So disjoint, in other statistics classes, we might call that mutually exclusive. Well, those mean the same thing. Okay. It just means that it can never happen at the same time. So, um, for example, uh, if I let's see, so if I pick a card out of a deck, and I ask, you know, what's the probability that I draw a three, and what's the probability that I draw a ace? Can those two things happen at the same time? If I pull one card out of the deck, well, I can't draw a three and an ace. There are no cards that are both a three and an ace. Okay. So those would be disjoint. Okay. Not disjoint would mean what's the probability that I draw a three and what's the probability I draw a red card? Are there red threes in a deck of cards? There definitely are. So you can have a card that is both red and a three. Okay. Um, now that's disjoint. We also over here are going to be talking about independent and dependent. I know that this says circle one, but technically disjoint and independent, those are not, I guess those are not disjoint. So independent means that the first outcome does not affect the second. Okay. Independent means that the first outcome does not affect the second. Okay. Mathematically, on page 254 at the bottom, there's a multiplication for independent events. It says P of E and E2 and blah, blah, blah. So you don't need all of this stuff. You really just need E1 and E2. Okay. So I'm going to write it out a little bit differently here for us. So independent, mathematically speaking, if you try to figure out the probability of this event and another event, so that's why we have E1 and E2. Okay, but you can use different letters. You can do E and F or whatever, X and Y. All you have to do is you do the probability of the first event and multiply by the probability of the second event. Okay, so If this equation is true, then these events are independent, meaning they don't affect each other. Okay. So what would be an example of that? So let's go back to drawing a card. If I draw a card out of a deck and then I roll a dice, I don't know what game I'm playing, but apparently I'm playing a game that has cards and dice. It doesn't matter what card I draw. I can draw any card I want. It's not going to change the results of the dice, and vice versa. If I roll the dice, it's not going to change which card I get. Okay. Um, yeah, so another example of independent would be, let's say I pick a random person in the US and I ask, okay, what's the probability that that person has blue eyes, and what's the probability that that person is handicapped? Those don't really affect anything. So if I have blue eyes, does that mean I have a higher probability of being handicapped? I don't think so. Okay. So, yeah. So anyway, mathematically speaking, though, we're going to need this formula a little later. Last one is dependent, though. Dependent means that the first outcome does affect the second. Okay. So, uh, if something is disjoint, it's automatically dependent. So I know it says circle one, but we actually are going to answer this as two different questions. Okay. And we'll get lots of opportunities to do these ones. Um, anyway, so answer D, though, is a garbage question. We are not, you can answer whatever you want for that one. I'm not going to mark you off if you, whatever you answer for answer D. I mean, we can look at it, but feel free to just circle something for D. Um, okay, moving on. Down here, so the probabilities, classical, empirical, and subjective. So you'll find that information on page 125 and page 128. Classical means theoretical. So theory, or you do a bunch of formulas. That's classical. Empirical means you have a measured experiment. So, and these two are related. So, classical, we can talk about. So for example, if I'm talking about like, what's the probability that I draw a red three out of a deck? Okay, that would be classical until I actually do it. Okay. If I actually go and say, okay, I'm gonna actually test my theory, and I'm gonna, get a deck of cards and draw one card from the deck and do that over and over, do that 100 times and measure my experiment and record the results. That's now empirical. Okay. The last one is subjective, and subjective is just made up. Um, that's not to say it's not useful, but if I was talking to my friend and I told them, yeah, there's a 50-50 chance that I'm not coming to the game tomorrow. Is there actually a 50% chance? Like, is there some kind of, flip a coin that I'm going to do? No. Um, but that's still useful information. If I tell my friend, okay, well, there's a 50-50 chance I'm not coming tomorrow. Um, they can plan around that. They can say, okay, he might be there, he might not. Okay. So it's still useful. Okay. Um, anyway. Okay, so that's page 390. You're on page 391. Which of the following numbers cannot be the probability of an event? So there's three answers here. So make sure you answer all three. Okay. So you're going to need to circle three of these numbers. Okay. Next one. Uh, this following table shows the probability distribution of blood types and rhesus factors for a random sample of people living in Quebec. Okay. Um, so This one right here. So we're going to get a lot more chances to talk about disjoint and not disjoint, independent, dependent. Okay. Um, as you're going through here, you're probably going to want to circle two answers, one for disjoint or not disjoint, one for independent or dependent. Okay. Um, technically, if you circle one answer, it might be sufficient. Okay. Um, but we'll talk more about that as we go. All right. By the way, when it says right here for a single person, A and B blood types, there's an A type, there's a B type, and there's an AB type, which is a completely different type. Okay. So A and B together does not make AB. If you had them together, you don't get that one. I don't know why it's not just A, B, C, but I'm not a I'm not a health guy. I'm a math guy. So um okay. Next page is page 592. So on this page, we're still continuing with blood types, and we'll get a chance to actually calculate probabilities. So remember that a probability is equal to the number of wanted outcomes divided by the total. Okay. So for example, if I'm asked what's the probability of Rh negative, then I want Rh negative, so how many people have Rh negative, and I divide by the total number of people. Okay. And then calculate that out with four decimal places. Um, so for this one right here, we have and or. Um, and when you calculate, so Um, and or in mathematical terms, especially like in statistics or logic, they mean something a little different than they do in English. Okay. So when I say I'm looking where both of these events are happening at the same time. Okay. That means if they're disjoint, then that means the probability is zero because if they're disjoint, they can't happen at the same time. Okay. But in general, you just look for where they line up. So for this one, I want AB and RH positive. So AB, RH positive is right here. 48 is my wanted, and then you divide that by the total. So and is usually pretty easy. Or on the other hand, is much more tricky. Okay. So with or, um, you're asked, I want to see what's the probability that someone is type O or negative, and they could be both. Okay. And again, that's a little different than what or means in English. Okay. If I told my kids, do you want to have ice cream or a popsicle after dinner? And they say, oh, I want both. I'm going to be like, no, you can't have both. Right? So do you want this one or this one? That is actually an exclusive or. I'm saying, do you want this one or this one? And really, I'm only offering one of them. Okay. But in terms of math, in logic or statistics, or means it could be this, it could be this, or it could be both. Okay. So to do that, on the bottom of page 254, there is a equation, general addition rule, which is if you want to calculate the probability of event E or F, you do the probability of E by itself, probability of F by itself, and then you have to subtract where they both happen at the same time. You have to subtract the and, okay? The reason why is because otherwise you're double counting, okay? So for this particular one, uh, type O or negative, I would say, okay, here's type O. So if I add these two numbers together, I get 583. So there's 583 people that are O, that have O blood type. Uh, I also want negative. So if I add this plus this plus this plus this, there are 222 people who have negative blood, negative rhesus factor. Now, if I add those two numbers together, the problem is that I've added the 94 twice, right? If I add these two, I get this. If I add all of these, I get this. The 94 is in both of those. So I have to subtract where they match up. I have to subtract the intersection of the two. I have to subtract the and because otherwise I'm double counting. I don't want to exclude those 94. I am still counting them. It's just that I don't want to count them twice. Okay. All right, so be careful with or. Now, one thing to point out is that there's two equations for or, probability of E or F and probability of E or F. How do I know which one to use? Well, you would ask yourself if it's disjoint, okay? If it's disjoint, that means that the two events cannot happen at the same time. That means that probability of E and F at the same time, both of those happening, is actually zero. So when you subtract zero, you get nothing. So this is actually the same formula. It's just that this one, we didn't actually write out the minus zero because you don't need it. Okay. Anyway. Um, okay, so that all said, um, that's all good. Let's look at the last page and then we'll start doing some math. Um, the probability distribution shows the primary home heating fuel in New Mexico 2023. Okay, so uh, if something is a probability distribution, that means that the probabilities of the different home heating fuel types must add up to what? What number do these add up to? And you don't have to actually add them. If you know it's a probability distribution, then what do these add up to? Yep. Thank you. They add up to one. Yep. So you can say 1 or you could say 100% or 1.0. That's all the same thing, right? So 100%. Now, so this is a probability distribution. Um, if on the other hand, took a sample of all the people in the US and I wanted to see what's the probability of certain job types, I can't really build a probability distribution off that because there's a lot of jobs, right? There's only like 8 rows here. But if I tried to do that for jobs, I'd have like a million different jobs that people could do. So maybe I do like the top 10 or the top 100, but that's not covering everything. So it's not going to add up to one. All right. There's one more thing that I want to talk about, and that's this right here, at least one. So the probability of at least one event in uh, X tries. There's a formula for that at the bottom of page 254. At least one event E in N trials. And it gives you this kind of craziness. So you'll find that at the bottom of page 254. Okay. And it's 1 minus probability of not E, and then you raise that to the power of X. Or I guess they use N on the paper. That's fine. Either way is fine. This right here, you'll have to calculate first, and it's 1 minus the probability of E. So there's two 1 minuses that you got to deal with a pile of parentheses. So be careful with this one. Okay. All right. All right. So that's all I have for the hints for us today. Let's dive in.